This is part 6 of the chapter 2 lecture, and I promise you that this is the easiest lecture that you can find for the entire general chemistry term. We are just going to go over periodic table and categorize periodic table into different groups and segregate into different types of category of elements. So what we are going to do is we are going to study periodic table and how it is arranged, and if there are any common names that we could use. And by this time, you already know that element symbol is presented as with 1 or 2 letters, and it has two numbers associated with it. One is smaller number, we call it as atomic number. One is larger number, we call it as mass number. So now, you look at the way it is all arranged, some are tall, some are shorter, some are tall again, and some are kept away but shown that it is been removed from here and rearranged here. There is a theory behind it. We could spend entire maybe a day, couple days just to study how we come up to this point of arranging this periodic table. The short key is you don't really have to know. The short key is that it is called an octave rule, Every other 8th element shown to have different similar properties. That's why they chose to arrange periodic table like this. So in the way the periodic table arranged, thankfully, is that all the elements that are present in one group shown to have similar chemical and physical properties. So we are very much thankful to that. So let's dig into this trends in periodic table and briefly discuss whatever we can discuss here. Now, first things you need to know what we call the periodic table. So periodic table is arranged in such a way of having the periods horizontally and groups vertically. What is horizontally means is that horizontally they were arranged in a way of increasing atomic number. You see 1 here, and if you go across the period 1, you see 2. So it has 1 more atomic number. See 3 here in period 2, and 4 next to it. 5 next to it, 6, 7, 8, 9, 10. See, these are called periods across from left to right, and all of these are arranged in a way to increase the atomic number in 1 increments, except these 2 groups that were called lanthanides and actinides, which were kept separately even though their atomic numbers are different from here. They're just removed from here and kept separately because they're shown to have unique chemical and physical properties than this bunch of transition metals. We will come back to that topic. Now, if you see, the periodic table has 3 different colors. One is a gray color, one is a brown color, one is a blue color. So there is a reason why it is shown in 3 different colors. The reason is that it is categorized into metals. All this huge left side area of gray color elements, these are all metals. As you see, we have so many metals available in the nature, a lot of them. And the common characteristics or unique characteristics of metals is that they were good conductors of heat and electricity. They can do many other things, but they're so popular for conducting electricity and heat. And the blue color elements that are on the far right side of the periodic table, all of these are called non-metals. And they were poor conductors of heat and electricity. Thankfully, they were non-metals because we are mainly surviving our human body, or the food we eat is mainly made up of these non-metals, carbons, nitrogen, oxygen, and hydrogen mainly. That's what we are made up of mostly as well. So the brown color or the light yellow color elements that you see in the middle are called metalloids, and they shown to have intermediate properties between metal and non-metals. Right, so far we know how it is categorized into large areas of periodic table. Now let's dig into what is called a group. So you know what is period across, and we use it only a tiny bit and not whole lot periods, but we refer periodic table in terms of groups from top to bottom in the same column because they were much more useful, because that is how they shown to have similar chemical properties from top to bottom in the same column. Those are called groups. from top to bottom. So this is called group 1A, this is called group 2A, and this is called group 3A, such like that the group number is written on top of each element there, and all of the elements in the same group will use the same group number. So let's dig into few groups and their characteristics if we can. Group 1, excluding hydrogen, which should be here, but it is arranged here because of its number of valence electrons, which we get into later in this term. So all the metals in the group 1 shown to have similar characteristics. That's why they were arranged there, like lithium, sodium, potassium, rubidium, cesium, and francium. They were all in general referred to sometimes as alkali metals. So if you say alkali metal groups, people, or at least chemists, will know, oh, you were referring to group 1. And the group 2 elements are named as alkaline earth metals. And those are called beryllium, magnesium, calcium, strontium, barium, and radium. And these are all shown to have similar chemical physical properties, and they were called alkaline earth metals as its general name. And group 6A is popularly known as chalcogens. It contains oxygen, sulfur, selenium, tellurium, and polonium, and there were more as well. It is just not included, but all these elements from group 6. And group 7 are referred as halogens, and it contains fluorine, chlorine, bromine, iodine, astatine, and tessinium. I don't use that word much. And group 8 elements are referred as noble gases. They were called helium, neon, argon, krypton, xenon, radon, and argonesium. And all these elements inside from 3B to 1B, excluding 2B, is called transition elements, or specifically inner transition metals or inner transition elements. And the group here too are called outer transition metals, and specifically they were called lanthanides and augenides. That's all you need to know about the trends in the periodic table. And only part left in this chapter is part 7 of 2, and that will conclude chapter 2.